Hello everyone. Today we're dealing with lesson 3.7. We're going to be solving rational equations and inequalities with algebra. So a simple example to start with. We'd like to solve this equation, find the value of x that makes this equal to 4. What we need to do to start off is multiply both sides by the denominator, which is 3x minus 5. So multiplying by this common denominator on both sides, you can see that the denominator is going to cancel on the left-hand side. So I'm left with 4 equals 12x minus 20. And it's just a matter now of solving for x. So bringing the negative 20 to the other side, I have 4 plus 20 equals 12x, or 24 equals 12x. If I divide both sides by 12, I end up with a solution of x equals 2. And I do need to state one restriction. Even though we manipulated this, we do need to specify that x cannot equal 5/3. Let's try a harder example now. In part B, the first thing I'm going to do is factor the denominator. And I'll factor the denominator on both sides. So we end up with x minus 5 over two numbers that multiply to negative 4 and add to negative 3. I think that's x minus 4 and x plus 1. And that's equal to 3x plus 2 all over x plus 1 times x minus 1. Next, I'll multiply both sides by the common denominator of x minus 4 times x plus 1 times x minus 1. So I'm finding a common denominator, and I'm multiplying both sides by that common denominator. So again, once I've multiplied both sides by this common denominator, I can see that I have some factors on the left-hand side and the right-hand side that can be canceled out. So canceling out those factors really simplifies this equation that we're working on. So now on the left-hand side, we're left with x minus 1 times x minus 5, and that's equal to x minus 4 times 3x plus 2. Distributing on both sides, I get x squared minus 5x minus x plus 5, and that's equal to 3x squared plus 2x minus 12x minus 8. If I'm trying to solve, I need to bring everything to one side of the equal sign since this is now a quadratic. So bringing everything to the right-hand side of the equal sign. I get 2x squared minus 4x minus 13. So I could have two solutions here since this is a quadratic. I could try and factor it, and I'd have to use factoring by decomposition. So I'd be looking for two numbers that multiply to negative 26 and add to negative 4. If I can't think of those numbers quickly off the top of my head, then I'm going to jump to using the quadratic formula to solve. So my solutions would be positive 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 13 all over 2 times 2. So I'm looking at 4 plus or minus the square root of 120 all over 4. Simplifying, reducing the radical, 120 can be divided into 4 times 30. And then canceling as much as I can, I end up with 2 plus or minus the square root of 30 all over 2, and those are my two possible solutions. So x is equal to 2 plus or minus the square root of 30 all over 2. And I should specify, again, my restrictions. X can't equal positive 4, negative 1, or positive 1. So those were two examples of equalities. Now we'd like to look at solving an inequality. So here I have 2 over x minus 5 is less than 10. I'd like to rearrange this so that it's in terms of something less than 0. So I'm going to bring the positive 10 to the other side of the inequality. So I have something that's less than 0. And then I'm going to gather my terms together by finding a common denominator that I can multiply 10 by so that I can add these two terms together. And that common denominator would be x minus 5. So distributing and then simplifying, I have negative 10x plus 52 all over x minus 5 is less than 0. And this inequality now is of the form ax plus b over cx plus d. So we're going to solve this equation now by graphing it. And based on the work that we did in class the other day, there's a series of shortcuts that we can use to graph this function. And so I've been able to identify my vertical asymptote, my horizontal asymptote, my x and y intercepts. And I can use this information based on those shortcuts to graph. So taking this important information, I've started to create a graph. I've marked in my scale. I've marked in my vertical asymptote. I've marked in my horizontal asymptote. I have an x-intercept at 5.2. I have a y-intercept at negative 10.4. Okay, the scale itself isn't important in the sketch. We're just using it to help us illustrate how our function looks. So I'm close to the asymptote, the vertical asymptote at x equals 5. I pass through my x-intercept, and then I flatten out as I approach the horizontal asymptote. And likewise, I'm near the horizontal asymptote at negative 10. I pass through the y-intercept, and then I flatten out as I approach the vertical asymptote. So how this will help us answer the question? Well, the question's asking us initially, where is this less than 10? We've manipulated this equation so that we ended up with something in terms of less than 0. And now it's easy to see, based on this graph, where our function is less than 0. We are less than 0 when x is less than 5, and we are less than 0 when x is greater than positive 5.2. So there's only a little area where we're greater than 0. If I wanted to do this on a number line, I would mark something like this. I would do an open circle at 5 with an arrow pointing down towards the negative values, and I would do another open circle at 5.2. So that's all we're going to do today. In class tomorrow, we'll start with another example, and you'll carry on with some C work.